Thank you very much for the kind invitation. Today, I'm going to talk about building a digital crystal ball, prospects and problems. The problems of the world are complex. We're faced with climate change, with financial, economic, and spending crisis, with conflict, mass migration, terrorism, and many other problems. And maybe the biggest problem of all is the lack of sustainability. That is a challenge so big that we really need a global effort to solve the problem. And we know this for a long time, actually, since at least 50 years, I would say, since the Limit to Growth book. And since then, people have been thinking about ways to solve those problems, and people were making efforts to map the Earth and its resources and what's going on the Earth. And this is what I'm going to talk about today. Maybe you have recently heard the Netflix series, The $1 Billion Code. And what I'm going to talk about today is, in a sense, a big version of that. The $1 Billion Code was about a project in the 1990s to map the world in 3D. And now we're basically having a $100 billion code. And so how is this basically going ahead? All of that is built on the digital revolution, of course. And we're living in a times of big data, no question. And there are many reasons to collect data, such as data is the new oil, to save the world, for security reasons, and also knowledge is power, of course. Chris Anderson, back in 2008, formulated a vision that we would see the end of theory. The data deluge would make the scientific method obsolete, he thought. And so basically people around the world, IT companies and secret services, militaries, have collected data as much as they could and tried to turn that into value. Business value, political value, whatever. And that actually encompasses a lot of data. So it starts from your shopping behavior, it continues over your mobility, the friends you have, the files you produce, and also the emails that you write. And if you think you're reading an ebook, then basically what the ebook reader does is it reads you. It tries to figure out your reading habits, your interests, and so on. Now, all of that goes on, of course. Now, every time you enter a search query, that will tell Google or some other company something about you. Same thing if you use Siri or some other voice-based assistant. And then when you watch movies, if you use a modern TV or even such kind of virtual reality glasses or augmented reality glasses, then of course this is telling somebody, some company, a lot about you and your environment and what happens in your living room. So the game engine would also basically record activities. And your robot that's cleaning home, and also basically the smoke detectors might have a camera built in. And why stop here? Some people would ask if we could also collect fingerprints and maybe even your DNA. And it goes on and go on and on. So basically all the data that are being produced, and it's a lot more than you would think, because there's a lot of sensors in your smartphones, for example, will produce a lot of information. And so the question is, would we one day know everything about what's going on Earth? Would we be able to understand the human body, brain, and personality? And yes, as you basically use the internet, that also produces a personal profile about you. There are a lot of cookies and other technologies tracking your behavior. There's some companies that have access to the data of as much as 64,000 social media providers. It's really unimaginable. And people have found bugs, computer hardware and software that allowed basically to read everything that you type. And of course, those data would tell everything about people. And then it doesn't stop there, because also your car, you have a modern car, is basically spying on you. There are a lot of sensors and computer chips in cars. And even if the microphone is not being used because it's a sensitive sensor, still possible to figure out what you say with other sensors that are not considered to be sensitive, such as the gyroscope or the accelerometer. I would tell somebody about your mood and also about what you're saying. So it's actually not that much we are saying over the day. It's not difficult to record it all in principle. If there's some microphone in the neighborhood, even if, say, you're digital detox and you leave your smartphone at home, but then you talk to somebody else who has a smartphone with himself or herself, and basically that would allow to figure out where you are, what you say, and to process that data, to translate it in real time and to search it for certain kind of keywords. And then also, of course, companies think about using cameras to figure out what's going on and maybe figure out your emotions and whether you're saying something truthfully or lying. And also it doesn't stop here, because now it becomes possible to remotely sensing heartbeats and EEG, that means your brain function. And already before that was possible, the Google CEO, Eric Schmidt, at that time said, we know where you are, we know where you've been, and we can more or less know what you're thinking about. And all that data also goes into mass surveillance, right? So we've learned Edward Snowden's revelations, and that was many years back already. So a lot of things have changed since then. I mean, that is, in a sense, an early stage of the surveillance society around the globe. We've later learned about the Vault 7 revelations, and yeah, that brings us to the $100 billion code, because I think they have spent $100 billion on hacking devices of all kinds. And Director Gus Hunt has actually warned the public by saying, you're already a working sensor platform, and it's very nearly within our grasp to be able to compute on all human-generated information. And now what will happen with all that data? Well, for example, we could try to build something like a crystal ball, right? Facebook is probably doing it. Palantir is doing it. I mean, the name Palantir basically means crystal ball. And there are some other companies such as Recorded Future and so on. And the idea is that we're now able to see what's wrong and to the system and the world. And of course, the military would also have such a prediction machine, most likely the most powerful one. And that data is basically bringing us into a new world, a data-driven world, and a new economy. And that new economy is characterized, on the one hand, as an attention economy. We're being overloaded with information, and basically what gets our attention can actually influence our emotions, our thinking, our decisions, and our behaviors. And so on the one hand, that attention is used to distract us from things that some people don't want us to pay attention to, and on the other hand, that information is being used to target us and to manipulate us, for example, to buy certain kinds of products. So we're living in a time where basically people are being influenced with personalized information and manipulated. And in the West, we call that the surveillance capitalism. So surveillance capitalism is profiling us. It's producing highly detailed profiles about everyone. We'll come back to this, how detailed it could actually be these days. And in fact, this is revealing our personality, in particular, our psychology, our desires, our weaknesses and strengths. And all of that could, in principle, be used for and against us. And it also brings us into a new society where there is behavioral manipulation. It could be used for better, like to make us behave more healthy and to protect the environment, but it could also make us buy sweet lemonades and smoke and go travel a lot and so on. So kind of is a double-edged sword, and I'm a bit skeptical it has been actually working to the better of humanity. So our choices are being manipulated. Tristan Harris, who has been working in a control room of Google, is even speaking of mass mind control. He thinks a handful of tech companies control billions of minds every day. And that's being used to fuel consumption, but also to make election outcomes. And in fact, this has been discussed in connection with the Brexit, but also the US election and other elections around the world in at least 65 democratic countries. And so in a sense, we've seen that weaponized propaganda AI has been used against us. AI that knows us better than we know ourselves. And in fact, human weaknesses, in particular cognitive biases, have been mapped out and are being used against us to manipulate us. And AI basically has figured out how to hack our behavior and our thinking and emotion that can be used by secret services, by companies within what they call neuromarketing, and who knows who is actually trying to influence us. Could be many people around the world, governments as well. All right, and the claim is that it would be used basically to the better of humanity. We would not behave in an optimal way, and that needed to be corrected by means of AI. AI would basically stop misbehavior by taking over control. And in fact, this is already working pretty well. And in fact, it's a bit scary to tell the least. And in China, we've seen one implementation that's called the social credit score. This brings big data and big brother together in a sense. Behaviors are being monitored in detail with cameras and all sorts of other devices, and the behaviors are being rated, and that gives a score, and depending on the score, you will have access to certain services and rights or not. And in particular, for example, citizens with a poor social credit score would not even be able to fly or to use public transport. So this could be really restrictive, and people call that often technological totalitarianism. We are also seeing this age of big data being used for new kinds of censorship and propaganda. Propaganda now, as compared to the propaganda that has basically been used to enter World War I on the side of America and to bring the Third Reich on the way. This very powerful propaganda is now personalized and even more powerful, and it goes so far that basically we now in what people call a fact-free, post-fact world where it's possible to generate what people say in a computer, even though they have never said it, and also to manipulate videos in real time. So basically, we cannot rely anymore on any kind of information on the internet. And when we talk about the metaverse, it will become pretty clear that we are already in that age. Okay. We're also seeing a new legal system where digital policing is being done in a data-driven way. Lawrence Lessig has said, code is law. So in this data-driven society, code is deciding more and more what is possible and what not. And so that really introduces, in a sense, new kinds of natural laws almost into our society, like in the Matrix. But let's not jump to the future. Let's talk about the uses at the moment. So pre-crime predictive policing is among this. And what is concerning is that there is actually a pretty high error rate, which is often way 90%. So there's quite a bit of arbitrariness and potentially discrimination in the use of these kinds of approaches. Similar approaches have also been used, by the way, to track or trace COVID-19 transmissions. And in some countries, actually, people who were infected were treated like terrorists, or at least in some countries, terrorist tracking software has been used. And that has also to the quarantine of a lot of people who were actually healthy. Because even in a data-driven world, with all that data that is available, there are actually false positives, false negatives, wrong classifications, and all sorts of errors. And that shouldn't be underestimated. Now, it doesn't end there, actually. We are seeing now a time where some people are pushing for a new human as well. So technological convergence is the key word, and transhumanism. And some people say the age of transhumanist politics has already begun. For example, with the Obama Brain Initiative, or also the Human Brain Project in Europe. We've also heard about Elon Musk Neuralink project. And so when people talk about upgrading humans by means of brain chips, we shouldn't be misled, because technology might actually be even much further than that. We may never see brain chips implanted into many people, because technological convergence brings now together computer technology with communication technology and with artificial intelligence and neuroscience and cognitive science and nanotechnology. And that basically brings, some people expect, a big technological convergence, and that would also bring a human-machine convergence. And so in the future, it would be impossible one day to distinguish man and machine. And some people think our federations would actually be machines. I'm not so sure about it, to be honest. But if you just project the technological trend into the future, that could be the conclusion that you would potentially arrive with. And the implication of this trend would be that maybe humanity would be lost altogether. Humanity as we know it today. Now, we are living not only in a time of big data, we are also living in a time of the Internet of Things. And so there are sensors, actually a lot more sensors than people on this planet, distributed in our environment, in our smartphones and technological devices. But also the idea of some people is that we would use nanotechnology to create an internet of humans or an internet of bodies. Nanoparticles or nanobots would basically be circulating in our body or be included in body cells and then report about body activities. And in that way it would be possible to measure the health status of people. And basically technology would be in our bodies, and not only what we do and what we think would eventually become accessible to computer technology, but also really processes down to the cells of our body. And that is something that would certainly sound very scary to a lot of people, also a bit skeptical about the use, in particular the dual use of these kind of technologies. And yeah, there are a lot of patents about this. And of course, that is of great interest to a lot of companies that think they can make billions on these kinds of developments. So the question, however, is how to process all that data. It's an insane amount of data that the Internet of Things is producing and will be producing. And of course, that brings us to quantum computers that are imagined to be much faster than normal computers, at least in the future, perhaps already now. And of course, that is to like military companies like Lockheed Martin, for example, but not only. And you see over here also, for example, Volkswagen Group listed among the users. So what do we have in mind? That's the question. Now, how to transmit all that data? That would bring us to new ways of communication, light-based communication, so-called LiFi or Li-Fi network would come on the way, where basically little diodes would be used to transmit data. Actually, I think it would be about 8 gigabits per second, just to give you an idea, if I remember well. And some smartphones are already in production that would be able to use this new kind of, more than broadband technology. I'm not even sure how that would be called in the future. So with that data rates, it would potentially be possible perhaps to transmit also a lot of data about our body and about our thinking. And this brings us to the Brain Initiative's mission. So back in 2013, Obama said that the US would spend, I think, three billions altogether on the brain initiative, and that brain was interested in using nanoscience and nanotechnology to provide a rich toolkit of novel methods to explore brain function by enabling simultaneous measurement and manipulation of activity of thousands or even millions of neurons. So it would be a really high resolution EEG, but one that could also potentially influence the thinking of people. And companies are preparing basically to do human brain indexing, to basically record the thoughts and the knowledge, and actually even people who think that we would upload our brain and personality one day in the future into the cloud or whatever it would be. And so basically surveillance capitalism would be replaced by neurocapitalism, where companies were not only able to guess our thoughts and our desires and nudge our consumption behavior and voting behavior, but they would really be able to read our thoughts and write our desires and behaviors into our brain in perspective. The question is, how far is that technology? What is clear is most countries don't have legal regulations, so-called neuro rights protected. And in fact, these nanoparticles that would potentially be able to influence brain and behavior, they already do exist. And what's even worse is that those particles have been detected in human brains. So how did they get there? And yes, Neuralink, as I indicated before, is really not the cutting edge technology when it comes to neurotechnology, I would say. And not only would it be possible to write information into our cellular behaviors through electromagnetic waves of the communication system, but it could also be using light. And that is going to the extent that it would also potentially be possible to use CRISPR to influence the genome and to basically influence those processes from the outside. So the question is, to what extent would our thinking in our body and our genetic makeup be influenceable by others from the outside? And of course, there are concerns of well-informed people like Miriam Meckel, who wrote this book, My Brain is Mine. All right, so now we are prepared to just imagine how far attempts to create a digital twin of this planet Earth would go. It would not only try to map the countries and the cities and the buildings, but also the people, their characteristics, personality, their behavior, their thoughts, and all of that is obviously the reason why we have this mass surveillance around the world. And now, could it be good for something? Well, people do have this idea that we could now basically save the planet and humanity and nature by controlling the world with all that information from a war room, right? And also, a consortium of companies around the world is collecting a lot of data and has partnered up with the United Nations basically to address the sustainability development goals, the Agenda 2030 is the key word, and also health issues, so planetary health agenda. Now, what will happen if you would basically run the world from such a war room in a data-driven way? If you imagine that, you probably understand better what's going on right now in the world. Now, these digital twins would really map not only where you live and what you own, what you do, what your friends are, but also it would really go into the most intimate areas of your personal life and secrets of your body. Now, you've recently heard about Facebook becoming Meta, and they want to build the metaverse. And this is basically showing you where we're heading. But in fact, it is not really, I believe, what is the end of the story. But have a look at this video of Mark Zuckerberg, because it will show you that most likely you're not seeing Mark Zuckerberg in the entire movie at all. It's just his avatar that is talking to you. Yes, and in the end, basically everyone would be mapped in the very detail of all our aspects of life and body. Some people get very concerned about it, including tech billionaires, and they are talking about the matrix. That means a world that is basically controlled by a giant computer system. And I think that we would need to learn how to break out of it. So can we escape technological totalitarianism? That is the question. So how could that be done? Well, first of all, it turns out that actually, even if you have a lot of data, it's not that trivial how to connect the dots. And also, creating a double requires a sophisticated learning approach. And learning basically is an approach which is iterative and takes time and would never arrive with an identical copy. I would say you could actually get quite a few things wrong, and that could be pretty dangerous. We also know that correlation is not causation, and a lot of the patterns that you find in big data, on the bigger your data set, the more patterns you will be able to find. There will be a lot of spurious correlations, meaningless patterns, even misleading or confusing patterns. And it will also be difficult to avoid, I would even say impossible to avoid classification errors. There are always false positives and false negatives, and actually the numbers could be pretty. So for every real terrorist, there are about 100,000 false positives, just to give you an idea. And moreover, there are physical processes that basically determine that the future is not controllable and also not fully predictable. A slightest change could actually, after a couple of days, lead to very different patterns on a macroscopic scale. And that would be a consequence of the physical phenomenon of turbulence. These are processes which amplify small deviations to larger and larger effects. And we know this also in other kinds of systems where there's a sensitivity which makes prediction difficult. In fact, there's a lot of uncertainty. We've seen that also during the COVID-19 pandemic. And we've had experiments with people where we have been able to reproduce the decisions that it have taken with a mathematical formula with 96% accuracy, which is really amazing, I would say. But still, that couldn't predict the right macroscopic outcome of the system. So there's a problem of overfitting. And sometimes, actually, if you add some noise, you would get better predictions of the macroscopic behavior. That means behavior of the system altogether. And that's, of course, what we're more interested in, I would say, than in the behavior of the single components or the single individuals, because it's the earth and nature and humanity that we care about. Of course, individuals as well, but it's there is this issue that there is optimum number of parameters. Adding more and more parameters will reduce your reproduction error of a data set you have at hand, but it wouldn't reduce the error in prediction. On the contrary, so basically, simpler models often have more predictive power. And that is, again, rephrasing the overfitting problem that I mentioned before. So, as I said in the beginning, we're living in a complex world, and complex systems are often capable of dynamical phenomena such as chaos. And chaotic systems, like turbulent systems, have this property that very small changes would really have big effects after some time. And we call that the butterfly effect. And the consequence is that if a system is unstable, a single individual could make a big difference and could change the system forever, to the better or worse. And that is a chance that we should be able to take fully to the better. Also, we need to realize that in the age of big data, yes, data volume is exploding, actually faster than processing power. So a lot of the data that's being created will never be processed and evaluated. There's something like dark data in a sense. But systemic complexity is growing even faster as we network the world. And that leads to a paradoxical situation, namely that even though we have better technology and more data than ever, we're losing control of the world as we try to control it in a top-down way. So we need a different control approach. Unfortunately, there is one, which is called distributed control. So, as I said, we're now living in a highly networked age, right? So, in this age, interactions, in fact, dominate over properties of the components of the system. So, rather than focusing on the components, for example, the individuals, we would need to focus a lot more on the invisible interaction and network effects, because they would determine the behavior of the system. And in these systems, we need to have a different approach in terms of control. In fact, we would need to give some autonomy to system components in order to achieve a high level of the goal function. So what I'm talking about is that network effects lead to self-organization, and the right approach in that kind of system is form intelligence, right? So in a networked system, everything you do would have an impact on something or somebody else. And besides the intended effect, there would be side effects, there would be cascading effects, feedback effects. Complexity promotes self-organization. But that doesn't need to be a bad thing, because it can be used to solve problems. And I'd like to illustrate that with the example of traffic flow. This is a very primitive example in a sense that shows you, however, that self-organization can work astonishingly well. But it's a matter of design. So what we have here is an intersection that has a unidirectional flow in the front and an opposite unidirectional flow in the back, and in between a buffer that allows everyone to adjust the speed in such a way to the traffic flow and to cross the flow. Now, this is inspired a novel of traffic light control, where the traffic flows control the traffic lights rather than the other way around. That means a bottom-up control approach. And it turns out that this can produce wonderful coordinated green waves, as you see in the video, but also it's actually able to improve the performance of the system for all the different modes of transport, and also it's going to be good for the environment. And that principle can be used also to reinvent our economy to make it sustainable. So we all know that we need to get away from those wasteful supply chains of today towards a circular and sharing economy. Just we haven't been able to build that kind of system because enforcing it by laws is very inefficient. But using the Internet of Things, we can actually measure externalities, external effects of what people do and what companies do on the local environment, like noise and CO2 and all sorts of waste and emissions, but also good things like health, education, and culture, and so on. And based on this, create feedback loops. And actually, what is really important to manage complex systems and even to allow complex systems to self-organize is that we wouldn't have just one control variable, as it's kind of common in the utilitarian system that we have today, where we measure everything in, for example, dollars, including the damage that CO2 would produce. Instead, we would measure the impacts of different kinds of emissions with different currencies and feed them back separately in a multidimensional way. And that would create a new socio-ecological finance system that combines the Internet of Things locally with feedback and incentive systems, and thereby introduce new forces into our economy that would foster a co-evolution towards a circular and sharing economy by everyone trying to improve the situation locally a bit. And as everyone is doing this, is going to shift the system towards an entirely new organization through co-evolution. So I do personally believe we're going to see another Galilean revolution. We'll need to change perspective. We need a new way of thinking about the world and a new control paradigm. And that is something that I've tried to summarize in a couple of books and publications I've written. Thank you very much, and that's it.
We might have some questions for you, and I'm asking the audience, do you have any questions? There is one scientist, Avelina Helm, please.
Hey, thank you. Okay. I hope you hear us. Thank you very much for this presentation. I have just a question regarding sustainability and all these topics that you explained here. How do you avoid another rebound effect from the increase of this use of technological power? How do we avoid another kind of unexpected setbacks that just arise and have arisen historically from the developments and are often unexpected? And the other question that I have for you is that how come that when we have so burning issues of environmental degradation and climate change, then we really put a lot of focus into all these aspects that you described, but we fail to directly employ them into really generating sustainability. It's rather in the kind of processing in the market and the military, and all these topics are covered, but it is still not yet focused on generating more sustainable world. So how would you comment on it?
All right. I hope I got all parts of your question. Was a long one. But I'd like to say one thing here, which I consider to be important, which is nobody in the world knows exactly how to solve a problem as big as the one that humanity is now facing. And that means we have to be experimental. We need to basically explore a variety of approaches. And we need to support each other and learn from each other. And we have therefore developed also a particular format that we call City Olympics or Climate City Cup, where cities around the world would engage in a competition with each other for innovations and implementations that would help to solve problems such as climate change, that would make the cities more energy efficient, more sustainable, more resilient. So there would be different disciplines of competition between the cities and all the stakeholders of a city, including politics, the media, companies, universities, but also civil society, and I mean NGOs, citizen science initiatives, and so on, would be able to participate in this format that you could imagine to be like a several months hackathon, but very practical, very much oriented at finding new solutions and implementing them. And then the best of those solutions would, of course, get an award, but also those solutions would be open sourced. And that means every city could pick that solution that has been developed by some other city around the world that would fit its requirements and its needs best. And companies could take those solutions, develop them further, combine them with each other. That means network those solutions. And this is how collective intelligence would really come about around the world as a result of a joint effort. Actually, many joint efforts, not just one. And so it would not be just competition that brings us forward, but also cooperation. Both of them would be combined with each other to really unleash collective intelligence on a global scale. That's the idea. And so we would evaluate those experiments, and thereby we would learn from each other. Of course, not all of these experiments would perform equally well. And so solidarity is also needed to support those who have tried out solutions that in the end turn out to be not as effective as other ones. But altogether, everyone would benefit from such an approach because, as I said, we need to experiment to learn what works and what doesn't work. And I'm pretty sure that the City Olympics through its cooperative component, would bring cities around the world together across cultures, and that this can be something that can establish peace, but also unleash synergy effects and symbiotic effects in a very similar way as we know that from ecosystems in nature. So I think we need to overcome this thinking that, oh, the resources are limited and now because of overpopulation a lot of people would have to die. No, what we have to learn is to innovate the system in such a way that we would unleash new symbiotic and new synergy effects that would make sure that we're reusing resources that are valuable and scarce, and in this way they would be enough for everyone. And I'm pretty confident that can be done, and we can learn from systems such as the microbiome, for example, and how those symbiotic effects can be created. I really wish that we would be able to create such a system that would really benefit from the socio-cultural diversity and the solutions that are out there and the ideas that are out there around the entire planet.
Just one small question. Do you think personally, can we escape technological totalitarianism, and then how, in which way?
I think we're much more advanced in terms of the implementation of technological totalitarianism than most people are aware. I know those who are basically running the show there would call it technocracy, and they're thinking they're doing a good thing, or claiming at least. And I'm skeptical because I do think it's really limiting the innovation capacity of humanity. And I don't think that optimizing the world would be the right approach. Because optimization sounds good, but you always need to choose a goal function, implicitly or explicitly. And a goal function is in the end a one-dimensional thing, a one-dimensional function, because you want to compare two solutions, and that requires greater or smaller comparisons. And that means in such an approach, the complexity of the entire world would be mapped on a one-dimensional function. And that is, of course, a terrible oversimplification. And the utilitarian approach behind that would be extremely limiting. And that means if you have such a utilitarian perspective on the world, then what you get is really an apocalyptic future where a lot of people would die. And that is, of course, something that we need to avoid in the first place. So I do think we really need to let this utilitarian approach and this optimization approach behind us, instead engage into what nature has been doing successfully for a long time, which is co-evolution. That means that everyone improve over the current situation and everyone respond to each other, and this way all system components in the system altogether will advance, and actually could advance quite quickly. I think what is holding us back at the moment is the historical past. So, and AI is not going to make it better, because AI is, of course, trained with data of the past and of the present. And that means it cannot see solutions that are not in those data of the past. now, where are we coming from? We're coming from a system that has been built around the resource of oil, gas, coal, carbon-based resources, the chemical industry, the auto industry, the air industry, the pharmaceutical industry, even the financial industry, very much the outcome of that oil-based business. And now, of course, they're realizing that oil is limited. And actually, wealth and power of those industries engaged when based on that resource is going to reduce after the day that we call peak oil, where the amount of resources that is being produced every day goes backwards. It's going less and less. And so they're afraid, of course, to lose power, and they're driving us into a new system that they have built that would keep their power, and that is a digital data-driven system. And I do think, yes, the world is faced with huge problems, but the best solution for the world is not necessarily the one that kind of keeps the power of the old businesses, right? Which in a sense have messed up the situation altogether. So I think we need to free ourselves from the interests of those players to be able to engage into new solutions and forms of organizations. And that requires really an open discourse in the first place that reveals the mechanisms of power and the interests that are behind those systems of power that we're faced with. And in this way, we can critically question that system and bring new ideas on the way. And I think we should also be talking a lot more about potential futures, right? So talk about, say, even science fiction scenarios, perhaps, to be open for alternative futures that will help us to free our minds. And it really starts with freeing ourselves from old, outdated thinking. That's the only way to break out of the matrix, I think.
Thanks a lot for making clear that there is no fundamental limitation for acting or thinking differently or organizing things differently. I think it was very useful to show that self-organization usually is a bottom-up approach that follows the rules instead of setting or bending the rules. And finally, thank you very much for showing that the increasing complexity is not necessarily our enemy, it could be our ally.